Hi everyone, it's Miss Johnson. We're going to continue our investigation about gravity, and we're going to explore the law of gravity that states everything that goes up must come down. So I have a wiffle ball here. I'm gonna throw it up in the air and it should come down. We'll see. I'll do this a few times. I want you guys thinking about that law of gravity while you're watching. So I threw it up, it came down, just like the law states. I'm gonna try it one more time. I'm gonna throw it up, and I want you guys watching to see what happens. I threw it up, but it did not come down. So I want you guys thinking about that for a few minutes and think about what stopped it, what made it not fall down to the ground. Hi guys, so you might have noticed in the outside video that the first time I threw the ball up in the air, it did fall right down to the ground. The second time I threw the ball up into the air, it got caught in the tree and it didn't fall right down to the ground. So the question is the third law of gravity still true? Does everything that go up come down? Yes. So eventually everything that goes up must come down. What you guys need to know is that things will fall down to the earth. They'll fall down to the ground unless something is holding them up. So I'm going to do one more example in here using my little fireplace room. So right now it is not falling down to the ground because I am holding it up. If I let go though, it falls right down to the ground. So everything that goes up will eventually come down unless something is holding it up. The ball in the tree, eventually it will fall down to the ground when the wind blows hard enough and it blows it out of the tree, it will fall down to the ground. So just remember that unless something is being held up, gravity will pull it down all the way to the ground. So the tree is one example. If something gets caught in a tree, it won't fall all the way to the ground. If I am holding something, like I'm holding this pin, it won't fall all the way down to the ground. Or if I catch something, I am keeping gravity from pulling it all the way down to the ground. So if you caught the ball, it wouldn't fall all the way to the ground because you're keeping it from doing that. For this next part of the lesson, we're going to look at how things fall down to the earth and if bigger things fall down to the ground faster than smaller things, or if heavier things reach the ground faster than lighter things. So I want to ask you this question. I have a dice, a softball, and a plastic horse. I want you guys to guess which one you think will fall to the ground faster if I drop them at the same time. So we're going to do a little bit of an experiment. I'm going to start with the softball and the dice, but I'll bring the horse over. So I'm going to drop them at the exact same time. And I want you guys to notice which one falls to the ground first, or if any of them fall down to the ground first. So they both hit the ground at the same time. Let's try this again, but this time with the dice and the horse. So I have the horse. The horse is much bigger and much heavier than the dice. I'm going to turn it on its side, flip the tail over there. So I've got them both. I'm going to try and let go of them at the same time, and I want you to notice what happens. Again, with the dice and the horse, they both hit the ground at the same time. So the cool thing about gravity is whether something is big or small or heavy or light, if they are similar type objects, so if they're solid, it doesn't matter the mass, they fall to the ground at the same rate. There is an exception. We're going to try this out again with a piece of paper and the softball, because I think that's the easiest to see from kind of far back. So I want you to notice what happens with the piece of paper. Let me move this other side. So I have the paper and the softball. I'm trying to hold them at about the same height. But I want you to notice, look to see if these two things fall down at the same rate like the other objects did. In that instance, the paper fell down much slower than the softball. And that is because of air resistance. So we aren't going to get super into air resistance. That'll be when you're a little bit older. But the air catches objects like paper or feathers or plastic bags, and they fall down much slower because they kind of go back and forth. So I would like you to try dropping some different items, make sure they aren't things that break, at your house, and notice if they fall at the same rate or if they kind of go back and forth like the paper did, and try out that experiment on your own. For the last part of this lesson, I'm going to challenge all of you second graders to use what you have learned about how objects fall and falling objects to make your own parachute. And I want to remind you that the goal of a parachute is to slow down the force of gravity. So if you're parachuting out of a plane, you don't want to go super fast. The goal of the parachute is to slow you down so that you don't hit the ground really hard. So I have just used some things that I had around my house. I used 2 sheets of notebook paper and taped them together. I used some leftover ribbon from some birthday presents, and I used a pin and I'm pretending like this is the little guy there, the guy who's parachuting. So we're gonna notice how this falls and see if it helps slow the pin down. So I'm gonna drop it from right up here. And that did a pretty good job. It went way slower than it would have, the pin fell way slower than it would have if it didn't have the parachute. So now that I've tried it with this, I'm going to make some changes to see if I can slow it down even more. Once you build your parachute, I want you, after you've dropped it once, to try and make some changes to see if you can slow it down even more. So up here, I have a plastic bag, and I chose this because I see plastic bags blowing around sometimes in the wind, and I notice how high up they can go and how they kind of stay up in the air sometimes. So I'm gonna try making a double parachute and see if that slows it down even more. Now at your house, so that you can see if it actually slows it down, you can use a timer and see if the second time around it's even slower, because that is the goal of the parachute. So now I have I'm gonna put one more piece of tape right over here. And it may work, it may not work. That's the cool thing about science experiments, is that you make changes, you see if it works better, you see if it works worse, and what improvements you can make. So I'm gonna try it again. I'm gonna make sure that this paper is from about the same height so that it's even and I can see if it actually slowed it down. So I want you to do the same thing. Build a parachute at home and experiment with it to see if you can make it even slower.